So, good morning to you. My name is Mark Radici. Welcome to the observatory. It's a beautiful spring day looking out the window. You can probably hear the birds singing in the background. And today I am going to make a power supply box for the telescope. So, if we go into the observatory, the problem I have is this down here. Now what I've got is a humidifier to keep the observatory, keep the damp out the observatory. I've got a 12 volt supply for the power supply for the mount. I've got the 9 volt for the electronic focuser, and I've got a dew heater adapter set up. And what I want to do is get rid of all this mess of mains powers and stuff. Just have one plug to plug in that then provides all the power out to all the necessary electronics, and then be able to unplug it from the mains and be able to plug it into a 12 volt battery as well. So that's the project for today. So this is what I want to do. I want to have a power supply, and that can either be mains with an a power adapter, or I want to be able to take my 12 volt leisure battery. So if I'm outside in our dark sky site or at a star party, it doesn't matter. I can either plug it into the mains or I can plug it into the 12 volt leisure battery. And the key point is I've got a 12 volt 5 amp power supply to use there. I'll need some sort of switch to be able to turn the box on and off, so when I go away at night it's still up and running. It'd be really useful as well to have a voltmeter. Trying to remember the symbol of a voltmeter. So a voltmeter, so I know what it is, so I can turn it on and off, and I can see whether I've got 12 volts of my power supply is dropping down as well. I'd also want to have some sort of USB charger, and the reason is I use an old iPhone to control my EQ6 over Wi-Fi. So being able to run the USB charger after a few hours, particularly in the cold, the battery starts running a bit low. So having some sort of way to charge up the old iPhone so I can run the mount wirelessly is really useful. And then I also want them running off that 12 volt bus. We're going to have the EQ6 mount, so that's going to have its own supply. We'll have to have the dew heaters, and that uses a cigarette adapter, to run that. I've also got the Skywatcher focuser, the auto focuser, and that annoyingly runs off 9 volts, so I need some sort of buck converter, step down converter as well. And as I was saying, so the USB as well. So I need one input with a switch with a voltmeter, noting that I'm either going to plug it into the power adapter so I can run it off mains, or I'll run it straight off the 12 volt leisure battery. And then the outputs are going to be the EQ6, the dew heaters using a cigarette lighter adapter, a 9 volt focuser, and the USB as well. Now, to protect all of this, I'm going to need some form of fuse box. So what I want to do is make sure that if the worst comes to the worst and I get a surge or short circuit or something, at least the electronics aren't damaged inside. So I've done some reading online. The EQ6 that's carrying the C11, reading online, doing a simple Google search, reveals that at max slew is drawing around about 1.75 amps. So that implies to me a 2 amp fuse is needed to protect the EQ6. The dew heaters, I found a really useful table on a website called Modern Astronomy, which is one of the UK retailers, and he has a table on there that describes the current draw depending on what size of optical instrument you're using. So reading across from that table then, a 11-inch telescope, a C11, is drawing 1.6 amps at max heating. A 50mm finder is drawing 0.35, and a 2-inch eyepiece is likewise drawing 0.35 amps. So that's nearly 2.5 amps. So that will be a 3 amp fuse for the dew heaters. And the important thing to note there, of course, that's at 100% heating, that's at absolute max heating. And obviously with the twiddly knobs on the dew heater controllers, I can often be down at say 40-50%. I very rarely have it up on full heat unless it's absolutely dripping and I'm already starting to fog over. So it's often going to be a lot less than 2.5 amps. That's only at max heating across all three. So a 3 amp fuse is there, just needed for that worst case situation. The focuser, the Skywatcher autofocuser, well, it's a pretty small current draw, so I put a 1 amp focus, a 1 amp fuse in for him. I've also got the USB charger as well. That's going to be providing the iPhone current in the cold. Keep that nicely charged up while I'm running the SynScan. And what else have I got? A little red LED, you know, these little USB reading light things with red LEDs just to provide some background light. Again, they're tiddly little things, so I'll put a 1 amp fuse in there. And bearing in mind, this is all very much the worst case, I'm going to put a 5 amp fuse, just my inspection, on the input to the circuit as well. So I've got a 5 amp fuse coming in to protect from the power supply, and then I'll put individual fuses in across the fuse box as well for the individual components. That means if whatever happens, I don't know, the dew heater shorted out and burnt through or something like that, at least the focuser, the USB, the EQ6 will all, those fuses will still be carrying on working fine. So having laid out the design and the requirements for the power box, what I've done now is gone onto a fairly well known electronic auction site. Obviously with the lockdown still in place, it's not so easy to go out and buy components as we need them now. So this is the first thing I'm going to go for. It's a fuse box that holds obviously the fuses that come in. So that's going to protect the individual electronic components and the circuitry itself. Now I'm quite pleased about this find. I was trying to find a power switch, a USB supply, the cigarette lighter adapter, the power supply adapter, and the voltmeter. And a friend of mine suggested, well, you can buy these as panels for cars and boats and trucks and what have you. So, you know, for 11 quid, that's just everything all together. So I can wire this up. It's all 12 volts, obviously designed for use on the standard battery. So I've got the power supply on and off switch. I've got the voltmeter to check the health of the battery if I'm out in the field, or the supply that's coming from the main. So I've got the USB then to run my phone for controlling the mount over the Wi-Fi, and then the cigarette lighter adapter for the dew heaters as well. My only concern looking at this is going to be quite bright in the observatory, and it's obviously designed for use in the car, not for dark adapted amateur astronomers. So I might have to put a little switch in line with the voltmeter so I can just have a look at that when I want to, and then put some sort of coverings over these guys and the little LED in there so I'm not dazzled as my eyes get used to the dark. The other thing I'm going to order is a 12 volt to 9 volt DC to DC converter, and then I can run that in line, and that will help drive the 9 volt Skywatcher autofocuser, and that will just run in series and convert it down. And I haven't ordered this because I've got a few of these left over in my odds and ends bin in the garage. Is the chop block that connects all this together, so I can wire everything in and out of there. So I've ordered the fuse box, that electronic panel, the 12 volt to 9 volt converter, and then with wiring I've already got, with the chop block I've already got, I can wait for all these to arrive. I'm going to lay out a design in Fusion 360, and it's an online, it's free for home use CAD package, so I can lay that all out in there and then run that across to the 3D printer, and it can actually make it for me. So the first parts have started arriving, and one of the other things I have put on is on the mains adapter, on the 12 volt several amp mains adapter that powers the telescope. This is going to be the power supply for the whole box itself. I've put on an XLR connector. I've put the female one on the main, so obviously you can't stick your fingers in, and then on the power supply that's going to go to the box I've put the male as well. So that then, he says, goes together like so, and then that physically locks together, and that's not going to come apart in mid-session. And what I'll do on my 12 volt leisure battery, I'll put an equivalent one on as well, so whether it's a mains adapter or whether it's a 12 volt power supply, that will always be powered. And you see the fuse box has also arrived. It came with fuses, although this is obviously for car fuses rather than electronic boxes. So the only one I can really use is the 5 amp. They're 10, 15, 20, 25, 30. So I'll put those to one side and just keep the 5 amp as the main power supply. I've got a little bag of 1 amp fuses, so that will power the focuser and the other electronics as well. And I'll probably go and buy a bag of 3 amp fuses as well, and then they can power the mount and the dew heater. So those will all be there. Okay, so here is the part drawn up in Fusion 360. I've gone for a fairly simple lid. I thought I'll print the lid first. I could make this out of plywood or any thin sheet wood or something like that, but I thought I'll go for the plastic. And the important thing to note is that I'm using PETG, and the reason is that the usual standard plastic for home printing anyway is PLA. And that, however, plasticizes and starts to deform when it's at 50 degrees C. So even though we don't get that hot summers in the UK, max sort of 30 degrees Celsius or something like that, if I put it in the car, we go to a dark sky site on a summer day, it could deform. So I thought I won't take the chance. I'll print it straight away in PETG, and I've gone for black as well with all the car fittings on there and all the lights. I want it printed in black so it's not glowing in the dark. I've sketched out, I've measured up the parts as they've arrived, and I've put together just a simple sketch, and then I've converted that up into the 3D CAD drawing. So what I'll do now then is I'll put that on the flash drive, and I will then put that across onto the 3D printer. So this is why I'm a big fan of 3D printing. I'm sitting in the warm room now, and as you can hear in the background, I've got the 3D printer churning away. It's done about an hour and 40 minutes now, so it's got a few hours left to go off the electric box lid. So while that's up and running, I can have the lunar images that I'm processing and sending off to the BAA being prepared. I've got Photoshop, if I just scan over a little bit, on this screen as well. So that's the beauty of 3D printing, is that you can be doing something else while of course the machine is working away. So here we have then, we've got the mains power supply, and then you can see I put and I always forget this one, the XJR, whatever it is, the audio connector on, so that's ready to go. And then that will connect into there, so the two clip together. And then the good thing about that, as I was saying earlier, is that they're locked together so they don't come apart. So that's the power supply. I've got all my parts together, the switch, voltmeter, USB cigarette lighter, and they will tie on with those rings. I'm going to put a switch in series as well to turn the voltmeter on and off so it's not really bright. I've got the power supply for the mount ready to wire in. I've got the 12 volt to 9 volt power connector for the focuser. I've got a spare RCA as well that I'm going to put into there. There's the fuse box. So the ones that came with are 5, 10, 15, 20, 25, so they're going to come out. I'll replace them with 2 amp and 1 amp fuses as necessary. And then I've got the controller for the focuser as well. So this is the circuit diagram I've put together. So what we're going to do is have the power supply. It'll come in, it'll go through a 5 amp fuse. We'll then hit that first switch, which is underneath here. Hit that first switch, that's the master on and off. That will then, sorry, train just going past. That will then power in parallel the EQ6, the cigarette adapter for the dew heaters, the RCA connector for the focuser, the USB, and the spare 12 volt. And I'll put the correct fuses in as shown there, the ones I did earlier. So that's got a master fuse to protect the whole circuit, and then the individual components are protected as well, and they'll all come together onto a negative rail and go back to the power supply as well. And what I've forgotten here is it on these, I've missed off the 12 volts, and he'll need a voltmeter And I just need to put a switch in there as well, just to turn him on and off. Excellent. Right, I'll start soldering. Right, so that is all the positive circuitry wires. So it comes in through here, positive comes out into the switch then powers up the fuse box, so it comes through there, and then they will come out. One will go to the switch, but I can't wire that up yet because he needs to go through the wall. On the other side of the fuse boxes, we then have wiring up the RCA connectors, the mount, and the internals, and obviously that voltmeter will then come out through the switch. So what I'm going to do now is, of course, do the negatives all coming back into the fuse box, into the chop block, and the chop block back up to the negative terminal, back to the power supply. I've now wired in all the negatives, all the black wires, and what I'm going to do is do the same again. They'll all come back to the chop block. The chop block will then go back to the switch, and the switch will then go back to the negative. So that's the next job to do. I've also got my 9 volt, very confusing 9 volt supply, and I have the 12 volt to 9 volt DC converter. And what I didn't want to do is wire this up into one of the coax connectors, because I put a, not coax, RCA connectors. What I didn't want to do is have one 12 volt and one 9 volt, because then I've got the risk if I connect the wrong one, I can blow the electronics on this. So I'm going to put the DC converter into the where the battery would go. Right, so we're all fired up. Positive in, all the way through the fuse box, through the circuit, negatives out, back to the supply. So what I'm going to do now is plug the brick in, turn you on, plug the connectors together, and I've got the voltmeter, sorry, the multimeter set up, ready to do a check. So I've done a visual inspection, make sure there's no shorts, there's no loose wires, no connections. I've done a pull test, and I've done a continuity check as well to make sure we do that. And oh, the switch is already on, so if I put the switch on, USB powers up, and I put the switch on the side, the voltmeter, 12.2 volts, and you on, USB's coming out. So what I'll do now then is I'll just put the voltmeter onto 20 volts, the multimeter onto 20 volts. So we've got no current coming through. So if we do, so using center positive, so put you down there to the bottom, just checking this will be the power for the dew heater controller. We have 12 volts, where is it? So 12 volts coming out, I guess, good, out of the cigarette lighter. Slightly easier to do this on the RCAs. Oh, if we just start, there we are. We seem to have lost something there, let's try the other one. Yeah, 12 volts coming out of that one. Let's go back to this one then, just check. There we go, 12 volts. So we've got 12 volts coming through. So we know the circuit is good. I've done a visual inspection, and obviously when these aren't in use, these will be shut down. So that's bright to my eyes already. So I'm going to get some black tape and cut that over for spaghetti. So yeah, I'm quite pleased with that actually. So that's how it all works. I need to get some grommets or something just to protect where the wires go through the wall. Okay, so that's the 12 volt to 9 volt DC connector connected in now. I've just got to do the heat shrink when I go in, so we don't get a short inside there. What I'll do now is power you two together. That's on, that's on. You're on. Voltmeter's working, so we know the power's coming through. I'll just check I've got 9 volts coming out. Let's observe that end. So 9.2 volts. So, power on, blue light comes on, USB has come on, voltmeter saying 11.7 volts, the dew heater light is, there she is. Now if I've already got the mount on, let's go SynScan Pro. So the mount's moving, and last but not least, the 9-volt focuser. So the electricity is a success. So as you can see, the weather has been glorious for the last few weeks. We've had such good weather. I spent last week exploring the Herschel 400 objects in Virgo, Leo, Coma Berenices. So many faint galaxies, some really quite attractive. And I've also spent then this week as we've approached the waxing moon, as the moon's come back into the sky. I've been stuck on the lunar surface as well. And I must admit that the Power Box has been an absolute godsend. It's been so useful just to have one switch to turn on and off. Everything's there, everything's set up. So with hindsight, there's a few things I would have done differently. Rather than having the inlet power supply just coming in through the wall, or through the wall rather at that point, it would be nice if it had its own little connector so I could unplug that, but it doesn't really matter. Maybe a hinge lid would be slightly more useful than screwing the lid on and off, but I can always make another one day. So I'm quite pleased with that. I quite enjoy that. As I say, it looks quite nice as well. It makes it look like sort of an old radio, sort of antique style with that wood, stained wood. And then with the varnish on as well, I know it's not going to be suffering in the dew at night.